Alrighty-dighty pre-algebra. This is our last video, our last test, chapter 13. And this one's a doozy, not gonna lie. So what I recommend is before you even begin, gather for yourself maybe a whole sheet, half sheet, or something like that with a list of formulas. This you could include area, circumference, surface area. Like I mentioned yesterday in our Zoom chats, you're going to need to do surface area and volume of 5 different shapes. So this is going to be an extensive list, but if you do it this way, then you won't have to go through for every single problem and try to figure it out. Okay, so moving right into this, we went over number 1 in the Zoom call yesterday. Again, if I don't see work, you will not get credit. No work, no credit. I know what's able to be done in our head, mentally, and therefore if you just say, oh, but I did it in my head, and you don't show it to me, sorry guys, it's not going to fly. Do yourself the favor. Look, that's literally one thing that I put down. Just do that. Okay, that's all I ask. Okay, now looking at these first 4, again, I mentioned be sure to focus on the directions. For these first 4, it's asking for the area and to include units. So that's what we're going to do. This first one, it's the area, not the perimeter. And we included the units inches squared for anything area. Now, I want to focus in on numbers 2 and 4 because these guys are a little funky. First off, number 2, we're going to have 2 shapes. And so we're going to need to find the area of this one here, and then the area of this second shape here. Now for areas of triangles, we know, so I'll just label this number 2. For area of a triangle, it's 1/2 the base times the height. Well, with the information given, we don't have either the base nor the height. Now, what we can deduce is that since 5 is this length, the rest of this length is also going to be 5 meters. Right? A little bit of subtraction, pretty straightforward. And this length here is going to mirror this length here. So that's 6 meters. So it's going to equal 1/2 5 times 6. Which, since I'm multiplying 1/2 times 5 and 6, I'm just going to take 1/2 of 6, 5 times 3. So area is going to equal 15 meters squared. That's going to be this guy. And then this guy, you guys could figure out multiplying base times width, okay? Make sure you add them together and include your units. Now, this second one, number 4, is not going to be quite as simple. This one, we actually have 3 different shapes that we're going to need. And so what I'm going to do, now you might be able to pull off this as a trapezoid, but what I'm going to do is I'm going to make my life easy and do something like this. Let's see, let me make that actually a straight line. Now I've got this long rectangle here at the bottom. I'll call this area 1. This other rectangle here, area 2, and then the triangle as area 3. Now this one's going to be, again, difficult. So area 1, we know it's just going to be base times height. Area 2, now it would be base times height, but we shortened this length, so it's not going to be 6. It's going to be 4. 6 minus 2 is 4, right? Therefore, this guy is going to be 4, and this guy here is going to be 10 minus 7, 3. So this length is 4, this length is 3. Again, find the areas of all these 3 together, add them together, and give me the area in centimeters squared. Okay? Moving on. Again, for these word problems, I recommend drawing it out. So for number 5, we're looking for the length. Find the length. I have 150 feet wide with an area of 45,000 feet squared. So again, we know that the formula is length times width. Now I'm going to plug in what I know. I know the area, boom. I know the width, boom. So 45,000 equals length times 150. Solve for L. And again, length will equal something feet. Again, we're using the formulas. So the formula for area of a triangle, area equals 1/2 base times height. In this case, we're looking for the height, so I'm going to plug in the rest of the stuff that I know. So my base is 8 meters, and my area is 16 meters squared. So I'm going to have 16 equals 1/2 8 times h. There's a few ways I could go about this. I could just resolve this 1/2 times 8 right here, and then divide to find the height. I can multiply by 2, then divide by 8. There's a few different things that I could do in order to get rid of this and isolate my h, but just remember, height will equal meters, just straight meters. Okay. Number 7, a revolving sprinkler head sprays water from 20 feet from its location in the lawn. What is the maximum area? Okay, so we're looking for area that one sprinkler can rotate. Use pi. So since we're using pi, I know it's going to be a circle. And let's think about this. If I'm a sprinkler, am I going to be spraying from the side? No, because it's revolving. So something that revolves goes all the way around. So the sprinkler head sprays 20 feet from the center. So my radius is 20 feet. Okay, that should get you guys started. Now what we're going to do is we're going to find the circumference of a circle that has an area of 78.5 centimeters squared. Okay, here what we need to do is we need to deconstruct the area. So area equals pi r squared. We need to solve for r. So we're going to have 78.5 equals 3.14 times r squared. You'll need to divide by 3.14 and then take the square root. Then you'll have r equals something. Then you take this and put it into the circumference equals 2 pi r. Then you'll take this number, plug it in here, solve for circumference. Okay, again, we're deconstructing, solving for radius, and then we're inputting that here to solve for circumference. Again, circumference is going to be just in straight centimeters because it's perimeter. It's only one-dimensional. Okay, page 1 down. It will get a little bit more straightforward as we move along. This one, finding the shaded region. Okay, we have tons of information here. So we are going to need to, 1, solve for the area of circle. We have the diameter, so we're going to need to find the radius. 2, find area of This, if you see, it's got one triangle and then the same dimensions of the triangle, area of two triangles, which again, because they're the same, watch what I'm going to do. Area equals 2, because it's the same, times 1/2 base times height. What's 2 times 1/2? 1. So put the base and the height, and solve for that. That's a 1, by the way. And then subtract, oh, that should be 3. Subtract area of circle minus area of triangles. Shaded. Okay. We've done a few problems like that before. I think you guys will be able to figure it out. Okay, now this one, it's definition. Remember, we have two similar polygons. Corresponding sides have the ratio of 9 and 16. So let's say I've got this, 9 and 16. The ratio of their perimeters, remember, I think this might be from chapter 12, but again, it's applicable here. The ratio for the perimeters, same. But the ratio of the areas, squared. Square the ratio. Okay. 11, two similar triangles have perimeter with these ratios. Okay. So this one's pretty straightforward. So this one is 6, this one is x, and we've got the ratio of 9 to 25, 6 over x. Okay, solve for x. Don't forget your units. Two similar polygons have these. I think you guys will be able to figure that one out. Okay, now we go into the surface area and volume of a whole bunch of different shapes. And it's asking for both, right? Surface area is number 13, volume's number 14. And if you need to, use 3.14 for pi, and round the answer to the nearest tenth. Include your units in your answer. Okay, so we're going to find both surface area and the volume. We're going to use 3.14 as pi, and we're going to round to the nearest tenth. Okay, let's look at this first one, because this shape is kind of ugly. So this is a triangular prism. So the surface area, is going to equal the lateral surface area plus 2 times the base. Okay, so the lateral surface area is going to equal the area, or the perimeter of the base, times the height. Okay, well, the perimeter is, so these two triangles are the base. So it's 6 plus 5 plus 5. And then, so that's going to equal 6 plus 5 plus 5. And then the height is 7 times 7. Okay. So you guys can finish that out. Again, please show your work. And then the base is going to equal the area of this guy. Now we've got 4 times 6, 1/2, because it's a triangle. 4 times 6. Okay. Once you solve what L equals, plug it in. Once you solve what b equals, plug it in, solve for your surface area. Your surface area will be in units squared. So we've got meters squared. Okay. Now, moving to the volume, because it's a triangle, but it's a prism, the volume equals the base times the height. The area of the base is going to equal this. It's the same base. So once you figure that out, oh, look, you have it there and there. And then the height is 7. Pretty straightforward. But again, the volume will be in meters cubed. So don't lose track of that. Okay? Now, with these next 3, we only have 3 shapes on page number 3, just these 3. We've got a rectangular pyramid, a cone, just imagine this is filled with ice cream, it'll make this a lot easier, and the cylinder. Now, I'm not going to show you guys how to do this. It's a very similar process to the other ones. Just remember, for pyramids and cones, the surface area equals the lateral surface area plus only one base, right? I only have one square here and only one circle here. Whereas, so it'll be the same plus base. Whereas for the cylinder, it's still lateral surface area. Oh, the surface area, the total surface area equals the lateral surface area plus the plus 2, because I've got 2 circles, 2 base. Okay. On the back side, we have one final shape, a sphere. This one's going to be a lot easier because there's not multi-steps. The surface area is one formula. We already have the radius, so that's going to be super easy. And again, the volume is one formula using the radius. Now, the last 3. Again, they are they are verbal, so you're going to need to draw a picture. 23. A dairy is designing containers to hold 2 liters of milk. If the portion of the carton that will hold the milk is a square prism, okay, so that's easy, square prism. So I'm going to draw a square. I think I'll do my best to draw a square. Now, what's nice about squares is they have the same dimensions all the way through, right? If the portion that will hold the milk is a square prism, so I knew that, with the sides of the base being 8 centimeters, so this is 8 centimeters, this is also 8 centimeters. How tall must it be? So we don't know the height. How tall must the container be? Note 1 liter is 1,000 centimeters cubed. We're given centimeters, so we're just converting it so we have the same units. That's nice. So we know that the volume equals the base times the height, so that's what we're solving for. We have the volume as, well, 1 liter is 1,000 centimeters cubed, so 2 liters is going to be 2,000 centimeters cubed equals the area of the base, which you're going to need to solve for, and the height. Height is what we are trying to find. So figure that out. And I think it's going to want you to round to the hundredths place. So it's something point something something centimeters. Okay. 24. Jasmine measured the circumference of her basketball to be 34.1 inches. What is the volume to the nearest cubic inch? So again, we have the circumference, 2 pi r. We need to solve for the radius. We have this here. Solve for the radius equals whatever it does. And then you plug that into the formula for the volume and tell me the volume in inches cubed. Okay. Last one. Woo! Noah's Ark was approximately that long, that wide, that high. How many square feet of boards would Noah need for the outside of the ark? What's it asking for? Oh, it's asking for the surface area. 2 base plus lateral. So solve for that. Okay, guys, I think that's it. I think that's what we're looking for. And if you guys have any questions, let me know. Otherwise, love you. Bye.